Thanks for joining after lunch. I hope I can make it work and you're not too tired. So, quickly introduce myself. I'm nicknamed Mizu. Official name is Mizu Zunke, but everybody knows me by my nickname. So I'm CTO for the Software Monetization business unit, and wanted to talk a bit today about security of things and trust in that environment. Cool. Good. So what does it mean trust for you in IoT? Anybody some thought about that? What you would expect somehow? Okay, no worries. We're just after lunch. So just put some words around it. Like, I would see it like, well, we have somehow in IoT, we have the devices, we have a back end, we have maybe a mashup with a lot of players there. And if I really want to be acting in that field, trust is important. But what does mean trust for me? It means that, well, the data, for example, that I'm somehow getting from the field is correct, yeah? The device which is out there is acting as expected. It's not doing something that is, for example, violating privacy or things like it. It sticks to the rules, yeah? It is predictable what is happening there. So I have to take kind of control of this ecosystem that I can feel somehow trust there. So what is trust for you? How do you see what means for you that you trust somebody? Or how do you judge that you trust somebody? What do you base it on? Huh? History? History, yeah. Faith, okay. Good, yeah. Maybe let's take a shot kind of at history. So I phrased it a bit differently, but I think it's probably going along the same direction. Somehow there's a track record that this thing or that person has been doing the things that I'm interested in a way that I feel confident with that he's doing in the right way. Okay, let's do a bit of a test in an IoT framework for that. So this is a safe, well, relatively modern safe made by a company that is protecting money already since 1859. So they have quite some experience in protecting money. Okay, so what does this thing do? It is actually sitting at retail shops, and if somebody dares to come along with cash, yeah, and wants to pay with cash, in fact, the merchant can directly dump the cash into the machine. It gets registered there, and automatically seen how much is actually put in there. Adds the stuff up, takes a record of all of that, and at the end of the day, basically reports how much money has been going in. It will automatically credit to the account, even though the money maybe is not even taken up yet. And the company that's taking care of transferring the money can do all the planning where they have to go when, simply based on the risk of having so much money in which safe. So pretty sophisticated system to reduce the cost there and still to have the same properties for the merchant like he would be depositing the money right away. Okay, nice. So, but if you look now at this thing from the other side, you will see something interesting here. Some people might recognize it. This funny port with the 4 connectors, it's also called USB port. What does a USB port do at such a safe? So in fact, it turns out this is the maintenance port for the service personnel. Good, okay, fine. Good, it makes sense that they have something there, that they can do maintenance on the device. But what a security researcher would actually be curious about, what can you actually do with this USB port? So if you are playing around there, you will realize that, okay, this is a standard USB port. What is running here, in fact, is a standard embedded XP with a standard USB port. So what can you do on such a USB port? You can plug in a keyboard, you can plug in a thumb drive, a lot of things that you can do. So in fact, you prepare a thumb drive with some scripts that, after you have done some reverse engineering, obviously, of the stuff that you have actually managed to get there, actually first using a keyboard somehow to get out of the normal control interface there, looking at the file system and whatever there. And in fact, you can prepare a thumb drive You plug it in, and after a few seconds, the safe opens. Perfect, huh? So good protection. Okay, but in fact, this is not all yet, because this thing here also is, well, trusted in the sense of that it's collecting, not only protecting the money, it's also doing all the accounting. Now, the good thing is that with this port, you can actually get full control, because basically you can also boot from there. You can replace the admin account. You can change whatever you want there. It means that also the tracking of the database and whatever what's on there, you can purge the records from actually the money depositing. The money depositing never happened. So perfect theft. Okay, so simply trusting somebody who is in the business since a long time is not simply transformable into IoT devices. Okay.
No, but it's never been like broken then.
Yeah, exactly. Yeah. You're right. You're right. The safe itself is perfect. Probably getting in there, I don't know, and using some dynamite, it will be difficult.
So what's wrong with that?
It's a matter of expectation, correct. Okay, so in fact, I would experience something else if I say I'm trusting this thing, yeah? Because then I shouldn't be able to get so easily to that. So maybe let's try a different approach. How about thinking about an external independent audit about such a device? Okay, good. Let's take another example from the field. Doesn't, for the first look, maybe look like an IoT device, but in fact it is. This is a sniper gun, which has technology that you know from, well, from movies with planes, where you have tag and shoot, basically. You have a visual display, a display, basically, where you are tagging your target. At the moment the gun is really in the right position, it will automatically fire. For this to be accurate, and they are actually saying that you can shoot up to a mile distance with that, you have to do some configurations there. You have to tell it exactly which ammunition it is. The weight of the ammunition is obviously derived from that. What is the wind speed? What is the temperature? How far is the target? Okay, good. So these days, how are you doing that? How do you configure an IoT device? No idea?
Over the iPhone.
Yeah, exactly.
But what's the definition of IoT device? You're using this term, but what
Yeah.
do you understand?
IoT device, I would say it's a device which has some network connection to the outside world. As one example. IoT device can be very diverse. In this case, I'm using it for that.
IoT, you mean network connection to like any network or like internet, or it doesn't matter? Or?
Well, I think you can push it in a lot of direction. You can say the moment it is something is having a connection, yeah, you are opening new interfaces, you're getting new threats. This is somehow, I would say, the minimum definition. If you take about the real IoT in the full sense, then I would say it comes not only to the devices, it comes also to the backend, it comes to the full ecosystem. Then you're talking really about talking between devices and not only like this gun, for example, talking to your cell phone. Okay.
I mean, from USB port is also kind of interface. So even if it's not really a network.
Yeah, but that safe, for example, is also talking really over the internet and reporting the information. Okay, so in fact it is having a Wi-Fi server, and you have some application where you can configure all of that. Okay, nice. Good. So for the user to make feel safe, in fact you can set some passcode, 4-digit number, to in fact lock the device. And, well, you have to enter the passcode actually to unlock it. Nice. Okay, all looks fine. So, very quick analysis. Wi-Fi server, the SSID is simply derived from a constant string plus a serial number from the gun. So, very easy to recognize that it's actually the Wi-Fi of that gun. Second thing is, the passcode to access the network is the same for every gun. Yes? Okay, so that's not really difficult to get to. And also the next thing, what was not so nice about it is the passcode. Okay, the passcode is for actually well, you cannot really fire it, but the passcode, for example, is not used that you can lock it against changes from the API. Because if you really modify the settings here, and they have shown this also in an experiment, they increased the weight of the ammunition, and in fact, the target was 1 meter to the left. So shooting 3 meters to the left and where you're aiming might not hit the same person. Okay. Okay, good. So already some flaws with this quick analysis. But, okay, this is not really, well, there are some things which are not nice, but let's look a bit further. Obviously, there is a nice machine in there. In fact, it's running Linux. And they also did some things very well. They have basically coming up in single user mode. The USB ports are disabled. The firmware update that can be done has to be digitally signed. So quite some reasonable properties how it should be. But they wanted to understand the things a bit better. And they looked at the file system. Obviously, you cannot access the file system directly. So they had to unsolder the memory chip. And in fact, read out the memory chip, look at the file system, what's in there. And what they ended up in discovering is that, well, the firmware has to be digitally signed, yes, but every public key that is in the trusted base is accepted for the signing. Yeah. Do I want Symantec to actually make an update for this one? Okay, I can say I trust Symantec. But maybe somebody installed an additional certificate and in fact was thinking about something totally different. Okay. In addition, there's an administration API, which also doesn't require authentication, which can always be used, which allows you to even much deeper configuration of the whole device. So, okay, nice. The good thing is that this deeper analysis took them a year. I'm sure it doesn't have to take a year, because probably they were not working full-time on it. But you see, they did quite some deeper investigations and invested some time and money really to get to these things. Okay, so what are the conclusions? A black box audit can bring some things, yeah. You will find out some things probably. But really to get to the really deep stuff, well, it will be very time consuming because you really have to invest a lot of, well, effort to actually get there. So the real conclusion for me personally is when you're doing a device that somehow has some chance of becoming a security hole for something, or might be mission critical, or might hurt your brand if it's not behaving correctly, you really should think about the whole security when you're actually doing the design process. So it means that you have to think about what are really your attack vectors and how do you actually, well, and you have to decide which ones you want to address. Maybe you don't even want to address everyone because some might be too expensive to address. And you have to do actually the right countermeasures. So I guess a lot of people are not really very familiar with doing such an analysis. And suggestion somehow for a first start can be, like if you take, for example, this gun, I think it has a very clear mapping also hinting in a certain direction already. This is actually a web server also providing services. So let's learn from how cloud services are protected. And for this, you can basically go to the OWASP, the Open Web Application Security Project. And they did a special survey exactly around also IoT devices. And these are the most common, well, security problems that they encountered. Yeah. Like insecure web interface that you didn't have to authenticate, or there was another very nice one, which is actually not so uncommon. The web server does not really perform the authentication. In fact, the web server gives all the accounts and the passwords to the client, to the browser, and the browser does a verification. Yeah, perfect, huh? I even can decide for which account I really want to log in. So really very, very awful what is really happening there in the field. Another thing is like you don't have necessarily different authorizations, so they don't have different roles, different accounts can do different things. Everybody's running basically under the administrator account, and so forth, a lot of things. So this is, I think, a very nice resource if you want to start thinking about what you should be doing about your device. They have really examples there what you should be looking at. So I think this is very helpful. Okay. So are we done? Stupid question. Huh? Why should I be asking the question? Obviously, I'm saying there's more. Okay. So what do you say when I put up this line here? Any thoughts about what this could hint to?
Sorry?
Yeah, sure.
I think it says that when you release the product, you might not find all the problems, which means you need to update it, maybe at a later stage to correct.
Right. We'll get to this on a later slide. Further ideas? There's a fundamental rule when you're designing a secure system. Don't bloat it. Only put inside there what is absolutely needed. And why is this? Because additional code creates additional bugs, it creates additional vulnerabilities. So in fact, what this should tell us, when you're looking at a whole operating system where several drivers are on there, whatever to support things, you can be sure that there are backdoors. So one thing you can be sure of is somebody is trying to find a problem, he will find a problem. So what do? In fact, you make his life harder. So to do that, you're actually protecting, against this analysis, which means that the crucial code, at least, that somehow could be there for potentially being attacked, you're encrypting it, you're using IP protection to make the reverse engineering more difficult. This picture here is, for example, showing obfuscation being used on an application. This is a control flow graph of an application. So you have some code block. It actually can go this way or it can go that way and so forth. And when obfuscation is applied, it gets a bit more complex. Obviously, there's also different qualities, if this is really helping and so forth. But I guess you get the idea. So you make the life for somebody who wants to understand the application, wants to find out where the security problem is, how I can actually, break into the system, very difficult. For example, if the software of the Jeep would have been protected against reverse engineering, they would have had a much harder time. Because, in fact, the analysis helped them to actually mount the attack. Good. So this is on the complexity side. So the complex system will have problems. But what does this also mean? You shouldn't really rely on it alone. It means that if you have some code, this is, the heart of the system, which actually provides the value for the customer, which is, crucial to work correctly for your whole, the whole data maybe that you're providing to the ecosystem, or if this is not working correctly, might hurt your brand. You should also look at protecting this code itself, so that the code itself can also still defend itself when it's sitting in this potentially compromised environment. So for this, there are tools, and also some of the tools that we are doing go into that direction. Envelope, for example, is going that direction also. So that this part of code is also, like other parts of the system, you could protect against reverse engineering, but also that it's monitoring itself against tampering. And this is, for example, some of the things that we're putting more into our software in this coming year here to beef up more there, that the application is monitoring itself. And then there's one more. If you think about a device behaving correctly, it's not only the software, because typically a software also has some configuration, and the configuration also influences the behavior. So also that these tools can help to maybe automatically verify that the configuration has been signed by the right owner, so that nobody has been tampering there. So that, for example, if an authorized service personnel would come and he would change the configuration, again, the data would be signed, so that it would again get accepted. If somebody else would be changing the data, it would not get accepted anymore.
And there should be a log where you verify that, right?
Or the application itself knows about it.
So
Right.
you query it from time to time to verify.
Basically, for example, when the file gets opened, do a verification of that. Yes. Okay. This question is now senseless because we already have the next answer. No worries.
It's your presentation, right?
That's correct, yeah. It would have been pretty impossible. Okay, we saw this slide yesterday, and I wanted to take this one as, you never know what happens in future. There will always be a problem. already Murphy told us if something can go wrong, it will go wrong. So make sure that you are able to fix your devices in the field. Bringing them back, bad user experience, the costs you don't really want to have incurring. So how to talk about this? The key thing what has to be there in place is that you have the piece of code which will accept actually the new firmware update or program update or whatever, has the secure access to a public key which cannot be changed even by an attack preferably, that will be used to verify the packet that you're getting. So that you know that the application itself, this protected code there, can verify this code that is there for exchange is really coming from you. So this is one of the most important pieces there, that you make sure that you have a public key sitting there that makes sure, that allows you to verify that the update is really coming from you. Okay, so what I would say are the takeaways. Well, consider who you trust. Experience alone is not necessarily helping. Definitely the most, well, it's like, I don't know, feel like repeating something that is everybody's saying anyway. In the design process already do your work about the security. Unfortunately, security is often very low in what you're looking at, but I personally believe we will have an incident happening in probably not too far time where really something bad happens because of an unprotected IoT device, which will probably then, I don't know, end in real problems, I don't know, influence on economy or whatever, or that at least regulations will be put in place which will make it like when you're thinking about SOX and compliance and whatever. So I personally believe things like that will happen, and well, do you want to be in the news like VW about such things? I don't know. So I think it's worthwhile to really look at that and invest in that in your devices. And well, we have, I think, seen that it's not simply I can easily make a shell around and everything's fine. There's a lot of ways how to get through it, and the complexity itself is causing problems. So also there, put measures in place to mitigate the problem. And, well, remember, Murphy is with you. Thank you. Any questions?
Maybe, just one word, I mean,
yes.
we have here one representative, which is coming from Trusted Labs of Gemalto, which is an individual unit within Gemalto, where even our competition is trusting or basically trying to assess where are the security risks within their code. So if anyone has some issue or
right.
some expertise,
right.
we are happy to.
I will happy to answer. I used to be until last week marketing manager of Trusted Labs, and Trusted Labs is a security consulting company and also a security evaluation laboratory to assess the security of all the connected applications, the connected devices, and can help to find the security threats and to recommend the countermeasures to protect it.
Good.
Can you go back to the last slide with the resources on it?
Yes, sure. Want to take a picture or?
No, that's fine.
Okay.
Let me take it.
Feel free. Any further questions?
Basically, it's not that different what we do with writing secure software, is it? What can you kind of...
Yeah, I agree in that sense if you're talking about software that's running in an environment that you can trust, yes. Yeah. The thing is somehow if you're doing a device, you might have more control over the whole device. You could be looking at secure boot, also making the whole chain secure, things like that. So there are some differences. But I think very clearly also that OWASP has been looking at that as a very clear indication that it's not really something that is falling from grace and totally new. Good, thank you.